Hello science fans, today, we are diving into the electrifying world of electrical power. And what is a key tool in understanding this power? You guessed it, it's the wattmeter. A wattmeter measures real power in an electrical circuit. Real power is the actual power that does useful work, like lighting up a bulb or spinning a motor. Knowing this helps us understand energy use, which is incredibly important for everyone. Wattmeters give us crucial information about power consumption. They help us see the flow of energy, allowing us to make smart decisions about electricity use. Wattmeters come in a couple of cool styles, analog and digital. Analog wattmeters have a needle that swings across a scale, while digital wattmeters display power as a number on a screen. Both types measure watts, the unit of power. The choice between them often depends on the specific application and accuracy needed. From checking the power drawn by a tiny LED to monitoring the massive consumption of an industrial furnace, wattmeters are the unsung heroes. They provide the data we need to innovate, conserve, and build a more energy-efficient future. So let's get ready to explore these amazing devices even further. It's going to be an illuminating journey, I promise. Science! Alright, let's peek inside. How does a wattmeter actually figure out the power? It's not magic, it's science. Most traditional wattmeters, especially the electrodynamometer type, have two main sets of coils inside: the current coil and the potential coil. The current coil is made of thick wire and carries the main current that the load uses. The potential coil is made of thin wire with many turns and is connected in parallel with the load. The magnetic field produced by the current coil interacts with the magnetic field produced by the potential coil. This interaction creates a force, or torque, proportional to the product of the instantaneous current and voltage. In an analog wattmeter, this torque causes the moving potential coil to rotate, moving a pointer across a calibrated scale. In digital wattmeters, electronic circuits sample the voltage and current, multiply them using microprocessors, and display the result numerically. The fundamental idea of combining current and voltage information is the same. Science is elegant. This interaction allows us to measure real power accurately. And that's how wattmeters do their magic. Not all wattmeters are created equal, folks. There are different types, each suited for particular tasks and offering varying levels of accuracy. One of the classic types is the electrodynamometer wattmeter, which can measure both DC and AC power accurately. They are robust and reliable but can be sensitive to stray magnetic fields and have limited frequency ranges. Digital wattmeters are becoming increasingly common. They use electronic circuits to measure power and display the reading on a digital screen. Digital wattmeters offer several advantages, including robustness against physical shock and the ability to measure a wider range of power values and frequencies. They can also include features like data logging, peak power measurement, and power factor display. This makes them incredibly versatile for modern applications, from home energy audits to sophisticated industrial monitoring systems. While some high-end digital wattmeters can be expensive, many affordable and accurate options are available for everyday users and educational purposes. It's all about using the right tool for the job. Whether analog or digital, wattmeters are essential for understanding and managing power consumption. They help us make informed decisions about energy use. So, choose the right wattmeter for your needs and start measuring. Science is all about precision and accuracy. Safety first, science friends. Working with electricity always requires caution, and using a wattmeter is no exception. Before connecting a wattmeter, make sure the circuit is de-energized. Turn off the power at the source and double-check with a voltage tester. Wearing appropriate personal protective equipment, like insulated gloves and safety glasses, is also a smart idea. A wattmeter has at least two sets of terminals, current terminals and voltage terminals. The current coil must be connected in series with the load, and the voltage coil in parallel. Pay close attention to the wattmeter's ratings to avoid exceeding them. Once everything is correctly connected, re-energize the circuit and observe the wattmeter for the reading. If the needle goes backward or off scale, de-energize the circuit immediately. For digital meters, an overload condition is usually indicated on the display. Always follow the manufacturer's instructions for your specific wattmeter model. Safety is an ongoing process, not a one-time checklist. Stay safe and measure wisely. Time for some hands-on science. Let's imagine a simple experiment to measure the power consumed by a 60-watt incandescent light bulb. First, gather your equipment. The light bulb in a socket, a wattmeter, and some connecting wires. Ensure everything is de-energized before making any connections. Connect the current coil of the wattmeter in series with the light bulb. Connect the potential coil in parallel across the light bulb. Double-check all connections for correctness and tightness. Energize the circuit and the light bulb should light up. The wattmeter will display a reading close to 60 watts. This simple experiment demonstrates the core function of a wattmeter. It shows us the real power the bulb is converting into light and heat. Pretty neat, huh? Wattmeters aren't just for science labs and classrooms. They are out there in the real world, doing important jobs every single day. Consider your home. The electricity meter measures the total energy consumed over time, which is what your electricity bill is based on. Simpler plug-in wattmeters help homeowners identify energy vampires, those appliances that consume power even when turned off. In the industrial world, wattmeters are critical for monitoring power consumption of machinery and optimizing energy efficiency. Precision wattmeters are used in testing and quality control for electrical equipment manufacturing. Educational settings rely heavily on wattmeters for teaching students the fundamental principles of electricity and power. Wattmeters are used in power generation plants to monitor the output of generators. Renewable energy systems often incorporate wattmeters to track energy production and efficiency. From the smallest gadget check at home to the largest industrial operations, wattmeters provide essential data. They help us make smarter energy choices and build a more sustainable future. Wattmeters are powerful tools that keep our electrified world running smoothly. They truly are indispensable. Like any scientific instrument, wattmeters come with their own set of advantages and limitations. The biggest advantage is that a wattmeter directly measures real power, accounting for the power factor to give you the true power doing useful work. Wattmeters are versatile and can be used in a wide range of applications. Digital wattmeters often come packed with additional features like data logging and power factor display. However, high-quality wattmeters can be expensive and require periodic calibration to maintain accuracy. Traditional electrodynamometer wattmeters can be sensitive to frequency and external magnetic fields. Digital wattmeters have their own complexities, and their accuracy depends on the quality of their internal components. Incorrectly connecting a wattmeter can give erroneous readings and pose a safety hazard. Despite these limitations, wattmeters are indispensable tools for measuring real power. They help us make informed decisions about energy use and efficiency. Use them wisely and stay safe. All right, team, let's quickly recap the electrifying journey we've been on with wattmeters. A wattmeter measures real electrical power, helping us be more energy efficient. They come in both classic analog styles and modern digital versions. We delved into the inner workings, discovering the magic of the current coil and the potential coil. The interaction between these coils creates a torque in analog meters or is electronically calculated in digital ones. We explored different types like the traditional electrodynamometer wattmeter and the versatile digital wattmeters. We also walked through how to use a wattmeter safely. Safety isn't just a suggestion, it's a requirement when working with electricity. Wattmeters are used everywhere, from homes to industries and educational settings. They have their pros and cons, but overall, they are indispensable tools. Understanding power is the first step to harnessing it wisely. Keep that spark of curiosity alive. So we've covered a lot about these amazing devices called wattmeters. We've seen how they measure the real power that gets things done. The science behind them is elegant, combining fundamental principles of electricity and magnetism. Now, I'm really curious to hear from all of you bright sparks out there. Have you ever used a watt meter? What did you measure? Were you surprised by any of the readings you got? Sharing your experiences can help everyone learn. What kind of watt meter did you use? Was it an old school analog meter or a modern digital one? Do you have a preference? Let us know your thoughts and why you prefer one over the other. And looking ahead, how do you think watt meters and power measurement will evolve? Perhaps future watt meters will be even more integrated into our devices, providing constant feedback. What are your predictions? Keep thinking, keep experimenting, and keep questioning. Stay curious, everyone.